Day 28, Honors Physics, Projectiles, problem number 33, Motorcycle Jumper. The diagram I have here, you should draw this diagram or just copy it. Once again, I've delineated my points A and B. A is going to be the edge of the ramp when they first jump off. And then the landing point hopefully will be, I'm just calling it right at the edge of the second ramp that you're landing on. Once you have the diagram drawn, you have your vector components of your initial launch velocity, the initial launch velocity of 30 meters per second at an angle of 10 degrees. Find your two components. You can do that numerically here, so you'll have a specific number here and here, which then will fill in part of your component format. You will have your horizontal velocity, the v sub x, which will be constant once again, and your initial vertical launch velocity. One of the keys to this problem is when you land at point B, the displacement vertically will be 0. You could also, in this case, put in your final velocity of landing as the negative answer of this number up here. For example, if this number right here is positive 6, this number will be negative 6 meters per second. You don't need to do that. You can if you want. It might be helpful. But the key is that S is 0, your vertical displacement upon landing, assuming the ramps are both at the same height, which I think is implied here, 0 meters displacement. So what you'll figure out then over here first is, since you have basically all 4 of these numbers, or at least 3, really 4, using uniform acceleration equations, you can figure out the time that she will be in the air. And once you have that time, you can put it over here. And you have the velocity figured out from the components. You could figure out the displacement that she can jump using v equals s over t. Once you have that, those are an extra step because you got to figure out how many buses this is. So for example, let's say that total horizontal s sub x is 32 meters. That means she can jump 10 buses because each bus is 3.2 meters wide. That's really cutting it close. But figure that out. You'll need to take this whole total distance s sub x and divide by the width of each bus to figure out how many buses you could put in this space right here for this daredevil motorcycle jumper. So, as you also see in the explanation here, we are ignoring air resistance. So once again, this would be the case if everything was perfect. She'll probably have to take a bus out of there. This physics will give you the maximum number of buses she can jump, assuming there's no air resistance, but air resistance would actually diminish the number of buses that she could jump. But let's just go with the maximum case right here, neglecting air resistance and going with the most precise measurements. Well, go to 2 or 3 sig fig, go to 2 sig figs here to see how many maximum she could jump.